Hello everyone, welcome to chapter 6. We're in 6.1, which is to add and subtract polynomials. Well, this is kind of lengthy, the section. You can see that we have 5 objectives, but it's a light section. It's just that it's lengthy. So we are asked to identify polynomials, monomials, binomials, and trinomials, determine the degree of polynomials, add and subtract monomials, add and subtract polynomials, evaluate a polynomial for a given value. Okay, you probably have heard about the word polynomials before, or maybe you haven't. We're going to look at it here. Polynomial, as you see, the word has some parts in it. Poly means many. Nomial means terms. Okay, so it's an expression that has many terms. That's a polynomial. So the next question naturally is, what is a term? Okay. So here you see the definition for monomial. It is a term that is of the form ax power m. Okay, so it's a term with a variable and a number, and the variable raised to a power. Okay, so as you can see, they say ax power m, where a is a constant and m is a positive whole number. The power is always a positive whole number. Okay, so your terms are a combination of numbers and letters, with letters raised to powers. That's what a term means. Okay, and if you look at polynomials, now polynomials are a string of terms, right? Polynomial means many terms. It's a string of terms. These terms are separated by either a plus or a minus. So you have like ax power m kind of terms. We have multiple terms with a plus or a minus in between them, separating them. Okay. So a monomial, right? Again, the word mono means single, monostereo, right? So that is a single term. So if a polynomial has only one term in it, it's called a monomial. Likewise, a polynomial with two terms is called a binomial. Think of binomial, bicycle, binary, right? That means two. So it has two terms. It has exactly two terms. And trinomial, obviously, is a polynomial with exactly three terms, right? Tri means three. So you could think of tricycle, trinity, triangle, right? Three. Keeping this in mind, we will move to the question of finding or determining if each polynomial is a monomial, binomial, or trinomial. Okay. Now, once we have crossed more than three terms, we simply call it a binomial. You only have special names for one term, two terms, and three terms. Okay, more than three, we call it a polynomial. So let's look at the first one. Okay, the first one has. I'll just show the first one explicitly here, but for the others, we can just go back to the question and respond right there. So 4y squared minus 8y minus 6. Right. This is a term. I'll just say term 1. Then there is a minus, so that separates it from the next term. It should either be a minus or a plus. We have a minus. That's term 2. Again, we have a minus that separates it. We have a term 3. Okay. A term is a mix of numbers and letters. But you can have standalone numbers or standalone letters, so that's still a term, right? So we have three terms here. So if there are three terms, what's the name for it? It's called a trinomial. Okay, that's the way you're going to identify each one of them. Let's look at question 2, okay? So 2 is negative 5a power 4b squared. Well, there is a minus, so is it separating it from some other term? Well, as you can see, there's nothing around the minus, right? Yeah, there is nothing in front of the minus. So you know that this minus is not the sign between two terms. It's actually a negative 5. The 5 gets a negative sign, so it's negative 5. So how many terms do you think we have? We just have one term. It is a monomial. And we also write it out here, trinomial. Okay, let's look at problem number 3. How many terms do we have? We have 1, 2, 3, 4, and 5. So we have 5 terms, and we don't have a name for it. We simply call it a polynomial. Then number 4, we have 1 and 2, because the minus in between separates these two terms. So you know that that's a binomial. 2 terms means binomial. The last one, that's a little weird. It just has a Q in it, right? Which is fine, because as we said, a term could either be a combination of numbers and letters, or simply a letter, or simply a number. We just have a standalone letter. But do you have any other terms associated with it? No. So this is a monomial. Okay. So done a good job here identifying them. Next, we need to understand the degrees of a polynomial. Okay. The degree of a term, right? Degree of a term is just one part, right? It's the sum of the exponents of its variables. Only the variables, only the letters that have powers, we have to add them up, okay? For a constant, right? For a constant is a number. For a number, do we have a term? For a number, do we have a variable? Constants do not have variables. So if there are no variables, you can't really add their powers, right? So for numbers, there are no variables, therefore the degree is 0. The degree of a polynomial, okay? Polynomial has many terms, right? For each term, you're going to look at the variable and see its power, and all the variables with their powers get added up. So if you keep looking at different terms, you will have to come up with the one that the term that has the highest degree, that itself becomes the degree of the polynomial. Okay. Well, I kind of explained it verbally, so let's actually do a problem so you can begin to understand what I mean by the degree. So there are 3 types of degrees: degree of a term, degree of a constant, and degree of a polynomial. Degree of a term is just that one single term, but if you have multiple terms like that in a polynomial, and if you found the degree of each one of them, the highest of them becomes the degree of the polynomial. And for terms that are constants, we do not have any degree. The degree is 0. Okay, keeping that in mind, we come to the first problem. 10 times y. Okay, 10 times y. Now look at the power for y. I don't see any explicit power, which means the power is always a 1, right? So there is only one term. This is a monomial. Therefore, the degree of this monomial is simply a 1. We don't worry about the 10. The 10 is a coefficient. It's the number attached to the variable. We're not interested in that. We're only interested in the variables and their powers. Next, look at 2. 4, slid off. 4x cubed minus 7x plus 5. Okay, this is a polynomial, right? Yeah, it's a polynomial. It has 3 terms, and according to the definition, we need to look at the degree of each term. So look at the variable here. The variable, we only have one variable, which is x, and its power is 3. Nothing to add because you don't have any other variables with powers for you to add. So you just write the degree here as 3. What about the next term? Again, forget about the 7, just look at the x. The power for x, you don't see a power. The x power is a 1. That's the only one you have. The last term is a number. It's a constant. The degree of a constant is always 0 because you don't see any variable. Okay. Now you have 3, 1, and 0. Out of the 3, you have to choose the highest one. This is the highest. Okay. So this is a trinomial, and its degree is 3. We'll do the third one here. Negative 15. I don't see any variable there. Actually, it's a plain number, right? So this is a constant. It's a monomial, but a monomial can be a constant. So the degree is 0. Fourth one is negative 8b squared plus 9b minus 2. Again, let's scan the degrees. The degree here, b, has the power 2. So that's 2. If we had another variable, we would have added it, but we just have single variables in each one of them. So that's making it a little easy for us. The power here is 1. This one is a constant, so that's a 0. So if you scan the highest power, that's a 2. So this is also a trinomial, and its degree is 2. 5. So we have 8xy squared plus 2y. This is an interesting one because we have two variables here. So x has the power 1, y has the power 2. So we have to add the two powers, 1 plus 2. That is a 3. That is the definition. We didn't see such a type all along, so we didn't get to add anywhere. But here we do. And here the y gets the power 1. I don't see the power, so it must be an explicit one. Between the two variables, between the two numbers, 3 is the highest degree. So this is a binomial. And the degree is 3. I hope that clarifies how we do the degree. Let's go to adding monomials here. So when we add two terms, right, we can only add them, or for that matter subtract too. We can add or subtract only like terms. Okay, let's write that somewhere. Okay, we can add or subtract only like terms. What are like terms? Terms that look alike. Okay. Alike. Alike means identical variable. It's all about the variable, okay? We don't worry about the number attached to the variable in front of it. It's the identical variable with identical power. That's how we know that, or exponent, right? That's another word for power. Identical variable with identical power. If they are matching, if they look alike, then we simply add the coefficients. Coefficient is the number that comes in front of the variable, right? So 25 is the coefficient here, 15 is the coefficient here. So that's what we are asked to do. So 25y squared plus 15y squared, they are identical in terms of their variables. So they are like terms. Like terms are compatible for us to add. If they are not like terms, you just cannot add them. So now we have to simply add the 25 and the 15. There's a plus in between them, so I know I have to add. If there was a minus, then I would subtract. Okay. So you don't add the powers for the y and all that. Please don't do that. Okay. You're only adding the coefficients. You keep the y squared, that's the same way. So 25 plus 15 is 40 y squared, and that is your answer. Okay. Please remember to add only the coefficients. Coefficients are the numbers attached to the variable in front of it. Let's talk about this one. Subtract 16p minus negative 7p. So 16p minus negative 7p, we have to combine the signs because you need to distribute it. 16p plus 7p. Now look at the two terms and see if they are like terms. Yes, the p and the p, like terms. Like terms means we can combine them, they are compatible. So we combine the 16 and the 7, only the coefficients, but retain the p as it is. Do not do anything to the p, just keep the p. And 16 plus 7 is 23p, and that's your answer right there. Okay. So whether we add or subtract, we always simplify them and then look for like terms. Now, if it is a polynomial, have a string of terms, the rule doesn't change. You still have to look for like terms. Okay, let me write that out. c squared plus 7d squared minus 6c squared. Okay. So as you can see, the c squared and this c squared, these two are the like terms. Just for convenience, I'm going to put them right next to each other. Okay, now the commutative property in math allows us to do that. We can't simply move things around. We do it just because of the property. Okay, these two are like terms, so I have to combine their coefficients. So there is no number in front of the c squared. So the coefficient actually is a 1. Okay. So go ahead and do 1 minus 6. Combine the coefficients, but keep the c squared as it is. 7d squared. 1 minus 6 is negative 5. C squared plus 7d squared. Now look at these two. The c squared and the d squared, they are not identical, right? They have the identical power, but they don't have the identical variables. They are not compatible. We cannot combine them. Please don't be tempted to combine them. Okay? So we actually stop the problem here and we box our answer. That's the end of the problem. Okay. So here we have to add two polynomials, right? We have two trinomials that we're trying to add. That's the question here. Again, the rule doesn't change. You simply have to combine the like terms. Okay. So let's write out the question. 5y squared minus 3y plus 15 plus 3y squared minus 4y minus 11. As we have seen plenty of times, when you have the parentheses, you want to get rid of it. You can't just drop the parentheses. Mostly, it involves distribution property. So distribute it. Because we have a plus, you don't see any effect on the distribution, but it is happening. The plus gets multiplied to each one of them, the sign. But it doesn't change anything inside the parentheses, so it appears as if we didn't do anything to it. Okay, so we have now successfully distributed and removed the parentheses. Now collect the like terms. I'd like to put the like terms close to each other because commutative property allows us to do it. And it's also easier for us to combine them. Eventually, you won't have to do that. You'll begin to see that and do it right away without having to write them next to each other. But we're just beginning on this section, so it's a good idea to take that extra step. So 5y squared, I need to look for other y squared terms. I'd see another one. Remember to take the sign in front of it as well. It was a plus 3y squared. Got that. Then I have a negative 3y here. Any other y's? Yes, I do see a negative 4y. So that's a negative 4y. Then there is a plus 15. Another constant is a minus 11. The only catch in all these moving things around is to remember to move the sign with them correctly. If we miss that, then we kind of destroyed the whole problem, right? Okay. All right, now we have to combine these two. So it's 5 plus 3 y squared, okay? And here you have a minus, okay? So that's minus 3 minus 4y. So just for clarity, I put a plus there in between because I'm taking care of the signs. And then plus 15 minus 11 is pretty straightforward there. 5 plus 3, 8y squared. Negative 3, negative 4 is negative 7, so that's a negative 7y. 15 minus 11 plus 4. Now look at the resulting answer. Are there any like terms? No, they are not compatible because y squared and y cannot be combined. They have the same variable, but they don't have the matching power. So you can't combine them. 4 is a constant, no way. So don't go beyond the problem. That's where it ends. So box the answer. Okay. Let's look at the difference problem. Find the difference of these two. Again, we have two polynomials. 9w squared minus 7w plus 5 minus 2w squared minus 4. Okay, here you actually see the importance of distribution. The minus must be distributed to eliminate the parentheses. So 9w squared minus 7w plus 5 minus times 2y minus 2w, I mean 2w squared, and minus times minus is plus 4. Okay, we'll collect all the like terms together. So we have 9w squared minus 2w squared together, minus 7w. There's not another term with a w, so we just put that. And then plus 5 plus 4. Okay. 9 minus 2 combines together, w squared. 7w has to stay 7w minus. And then this is 5 plus 4. Okay. So that's a 7w squared minus 7w plus 9. Always look at your last step and see if there's any like terms you probably missed. But mostly we take care of them, but it's always good to check. Again, the w's are common, but the powers don't match, so we cannot combine them. We have to stop right there. That's our answer. And we have completed all the objectives in this section. It's kind of lengthy, but you can see that it's not too bad. So I look forward to the next video with you. Thank you. See you soon.